Good morning, everybody. This is Carl Griffiths from Graybar. We're glad you've joined us today on our G2 Talk webinar. Today our subject is focusing on distributed antenna systems or in-building wireless, and in particular we're focused on the healthcare industry. So we want to welcome all of the healthcare professionals that are on the call with us today. We hope the information we provide you today will be very helpful. Before we get started, a couple of housekeeping items. Number one, if you're the first 50 people that are on this webinar and you stay with us on it, you're going to get an email that will provide you a certificate for a cup of coffee from a national coffee chain. So look in your email for that. Secondly, if you would like to review this presentation later, it is archived. So if you go to graybar.com and look for the G2 Talk webinar, or a G2 Talk logo on the home screen there, you can click near there and there's an archive section where you can pick up this information later. Thirdly, we want to let you know that there is a Q&A associated with this discussion today, so you'll be able to ask questions. The way you ask a question is to open the little question dialog box, and there's a little logo. The fourth one is red, and it says Q&A in it. If you click on that, a little dialog box will open, and you can type your question in there. And at the end of the presentation, we'll go over those questions. So we encourage you to keep track of your questions, copy them down, and we'll get to them at the end of the presentation. Before we get going with our presenter today, I would like to introduce to you Eric Tenges, and he's our National Business Development Manager at Graybar for our wireless mobility solutions and our wireless mobility initiatives. And this includes DAS for sure. So I'm going to pass it over to Eric just for a moment, and then he'll introduce our speaker.
Great. Thank you, Carl. So as you said, my name is Eric Tenges. I'm Business Development Manager for Graybar, primarily focused on DAS. And it's kind of an interesting topic today in working with healthcare because it's a very, very active market for all wireless technologies, and then of course that supporting infrastructure for wireless is the DAS. I've had about 10 years of experience in the DAS industry, both on the carrier side as well as in the systems integrator, and it's given me kind of a 360 view of the industry and puts me in a unique position now at Graybar in driving DAS to help our many customers figure out how to successfully deploy DAS. And what I've found over the years working with healthcare organizations, kind of a common denominator, is that there's a lot of confusion over how to deal with the many entities that are involved in deploying a DAS, the vast array of funding models that can be very, very confusing. And for most organizations, I've watched that add months and sometimes years to the process of getting that done. And so what Graybar can do for you is to help you find those right resources and those partnerships that Graybar has to design, deploy, maintain, very importantly fund, and then connect the wireless providers to your DAS. We're able to supply all of the major DAS manufacturers' active equipment as well as lots of passive equipment that is needed and give you that choice between the best-in-class equipment. We also are partnered all across the country with many carrier-qualified system integrators and installation contractors, and that's kind of a key point there. You don't want to be working with an integrator who does not regularly work with the cellular carriers because they'll have a hard time getting that DAS approved for connection, and you don't want to end up in that position. And probably most importantly, Graybar brings a knowledge of various creative funding models that will help you get your DAS off the ground, and whether that is working with the carrier funding, a neutral host company and their model, working through, say, a Graybar lease model, working with your own capital expenditures to put towards the project, or a hybrid of all of those different solutions in order to piece together that project for you. Graybar is there to help you navigate through all of that. I'm very excited to have today our main presenter, Alan Dixon, who is the National Channel Development Manager for Corning Mobile Access. And Corning is a great partner of Graybar. They're an absolute leader in the DAS industry today. And so he's got a lot of information he can help you with in his role of evangelizing DAS. And I want to point out one other thing about Alan that's kind of special. There's a group called the DAS Forum that he happens to be the president of. And this is an open organization of manufacturers, integrators, and end users in the DAS industry. and they are really dedicated to removing the barriers to deploying DAS. And so he's got a very unique perspective, both from the manufacturer side and as well as his leadership role in DAS Forum. So without any further ado, I want to pass this along to Alan and let him tell us about what Corning's doing in the healthcare space.
Excellent. Eric, Carl, thank you. I appreciate the kind introduction. I appreciate the opportunity to be able to address the group today. The folks that are on the line, thank you for attending. We appreciate you taking some time out to spend it with us today, and we hope the information that you receive in this presentation is informative and helpful. So this is the agenda that we put together. These are the kind of things we want to do. We're going to do a brief introduction to go over who Corning Mobile Access is and the solutions we have available. Then we're going to talk a little bit about cellular trends and how they're impacting healthcare today. We're going to talk a little bit specifically about DAS and how it's being implemented in hospitals and some of the special challenges around that. And then we're going to go into a little detail on a couple of Corning Mobile Access solutions. And of course, we'll leave some time at the end for questions and answers. So here's our introduction slide, and there's the first slide. So Corning Mobile Access, who are we? We are one of the leaders in the healthcare industry, one of the leaders in the in-building wireless space. We've been around since 1998. We're headquartered up in Vienna, Virginia. If you're nearby, stop by and say hello. We've done almost 5,000 installations worldwide. Specifically, we've done over 350 hospital deployments here in the United States. You can see a couple of our signature installations there on the right-hand side of the screen. There's Northwestern Memorial Hospital up in Chicago. You've got the Clarion Health deployment. We've got Banner Health in the Phoenix, Arizona area, and of course Children's Hospital of Denver. These are, again, just representative deployments of where we've put solutions in place. What makes us special? We are approved and recommended by all of the U.S. wireless carriers. So if you look at the bottom of the screen, you'll see that we've got the logos for Verizon, AT&T, Sprint, and T-Mobile. We are a solution of choice for these guys when they go specifically into the healthcare environment. One of the things that also makes us special is the relationship that we have with Cisco. Cisco generally does not like distributed antenna systems. What they really don't like is you running wireless LAN over DAS. On the other hand, we've developed a solution that we'll talk about a little bit later that enables us to run a DAS over a wireless LAN deployment. And that's something that they do like, and they've tested it extensively, and so we're proud to be able to put their logo on our page as somebody that we work with very, very closely. We've learned that it's very helpful to say Cisco as many times as you can during the course of a presentation, so you'll hear me say Cisco a lot. Occasionally I'll say Cisco. But anyway, we'll get to that. One of the other things that makes us different is we're the only DAS vendor out there offering integrated wireless medical telemetry support for both the GE Healthcare CareScape solution and the Philips IntelliVue solution. So we'll get to a little bit of detail of that as we roll through. So let's take a look at some of the cellular trends that are impacting healthcare today. So this is a pretty cool slide. If you look at it, what it talks about is what's happening to the world and what's changing out there. So if you look at the bottom right-hand side first, this is kind of where I want to start because it talks about devices and who's connected. So the starting point that we have is that in the U.S. today, we have achieved over 100% penetration. What that means is basically if you want a cell phone, you pretty much have a cell phone. In reality, what it means is that what we have is a lot of people who are carrying multiple devices. And that's what we show on that bottom right-hand slide, is these are the number of folks who are carrying mobile devices. So if you look at it, what we see in 2013, well, back in 2012, what we saw is about 12% of the subscribers in the U.S. were carrying multiple devices. That grew 3% between 2012. We were forecasted to grow 3% between 2012 and 2013. And if you look all the way out to 2016, they're forecasting that up to a quarter of the users will be carrying multiple devices. I think they're underselling that because I think that the number of folks that are carrying multiple devices today is underestimated. I have a feeling that pretty much everybody that's on the webinar today has a smartphone and probably a tablet. If not a tablet, then they've got a laptop that's connected using a 4G dongle or maybe a netbook or something along those lines. But they could be a Kindle that connects to the wireless network. But there are multiple devices out there and multiple opportunities, and we're starting to see several things connect up. So what's the impact of that on the network? The impact of that is that it's consuming more and more data. So now if we go up to the upper left-hand image, what you see is the amount of data consumed by device per month in exabytes. Now, I'm not exactly sure how many zeros come in an exabyte, but I know that it's a bunch of them. But if we take a look at it, what we can see is that there are three classifications of devices: smartphones, laptops, and tablets that typically that make up the majority of the data consumption. So you're looking at 80% of the data being consumed by those three classifications of devices. What does that mean to the network? Well, if you go back to a basic cell phone and relate that to a smartphone is the equivalent, or consumes the data equivalent of 35 regular phones. So if you've got a smartphone, it looks like 35 regular phones. And when I say a regular phone, I'm going back to the days when a cell phone was used to make phone calls. And when you looked at the device, it probably had 4 pieces of information for you. It let you know that you had power. It let you know how many bars of signal that you were receiving. It told you how much battery you had left, and it maybe told you that you had a voicemail message. So that's the kind of thing that we're using as our basic cell phone. And a smartphone is the equivalent of 35 of those. If you take and then hook up a tablet, you're creating the equivalent of 122 regular phones. And if you go to a laptop with a 4G-enabled dongle, you're creating essentially the equivalent of 500 regular phones. So now if we combine that slide with the first image that we looked at, the fact that people are carrying more and more devices, if you've got somebody who's carrying a smartphone and a tablet, what you're looking at is somebody that is consuming or representing the equivalent of 150 cell phones, regular cell phones, in that one space. If they've got a laptop and a smartphone, you're creating the equivalent of 535 users in that one little space. And if you look at a room where you've got multiple things like that going on, you can see now how it starts to impact the network. It's just starting to overwhelm things. So if we go to the next slide, we take a look at it from the same perspective. So those mobile devices that we're carrying, what are we doing with them? So if we take a look at the image on the top left of the screen, what it shows is an analysis that was done by a group called AppsFire back in January of 2011, and they looked to see what people were doing with their cell phones. And what they found out is they were not using them in the way that they were originally intended to work. A cell phone was originally intended to allow you to make a voice conversation from a remote location, a car, a bus, a taxi, walking down the street, to another location. But it was intended to support telephony, voice telephony. But if we look today, what we see is that about 70% of the time that we're using these devices, it is not to make or to take a phone call. Instead, we're doing things like checking our emails. We're doing social networking. We're downloading different webs or web applications, things like Foursquare or Facebook or things along those lines. But regardless of what we're doing it with data and not with voice. That's the slide to the image to the right indicates the same kind of thing. What we see is what types of applications that we're using and the amount of data that each one of those consumes. The dominant application that's happening on the wireless network today is mobile video. And you can see that in 2013 that it consumed a significant amount, probably about 60% of all the data traffic that's going across the wireless network was in the form of video. And that's forecasted to increase as we move out to 2016, where we would see it probably representing about 75% of all the data that's being consumed. So the idea is that as bandwidth becomes available to the subscribers, they will use that bandwidth and it will drive additional growth. So faster networks lead to additional data growth, which means that as we look at the network itself, it's not only important that we provide voice coverage, we still have to do that. That's table stakes. But we now have to provide both data coverage and capacity to support the users that are on the network. So what we're looking at is the carriers having to reinvent themselves. So they're going from being an organization that provided voice coverage outdoors to a company that provides voice coverage outdoors and data capacity and coverage in an in-building environment. So they're basically having to build this airplane while it's in the air. So let's take a little look at deaths in hospitals and what's going on there. So in the first place, why are we talking about this? Why do buildings have problems with cellular connectivity? And it's really kind of a simple explanation. What we have is that RF signals that are generated from outdoor cell sites, which is where the majority of the capacity is in the network, don't get into buildings because of problems moving through building materials. Those building materials that make up the exterior of the building, whether they're masonry, brick, concrete, wood, whatever it is, acts as a barrier to the signal. So the signal can get through it, but it loses power as a result of that. As we move to things like green construction, it gets even worse, because where it used to be that if you had a problem with inside a building, what you would do is naturally migrate to the exterior of the building. You'd get to a window so that you could stand there because your signal seemed to be better near the window. Well, that was because the window offered very limited blockage to the signal, if you want to call it that. A masonry exterior can knock down as much as 29 dB of the signal. So 3 dB is about 50% of the power. So if you're looking at 29 dB, you're looking at having like less than 1/10 of 1% of the power that was available on the outside of the wall available on the inside of the wall. A window, regular window glass, only knocks down about 3 dB, so you only lose about 50% of the power. So you do get better signal near a window. The problem is, as we move to green building design and construction, we're moving away from standard window glass and we're moving to the new low E glass. And what low E glass does is it very, very effectively stops RF from getting into or out of a building. So not only can you get the signal into the user, you can't get the user signal out of the building to the network. Add to that the fact that hospitals are notoriously messy RF environments. There's a lot of wireless gear inside a hospital. So there's lots of different devices. You've got imaging devices. You've got microwave ovens. You've got laptops. You've got lots of different things that are going on there, and they're all kicking different signals into the air. Then you take and add the additional complicating factor that hospitals throw up a lot of shielding that is there to protect the staff, to protect the patients, to confine things. So you look at lead that goes into the hospital as part of the construction of the building. So initially those areas were fairly confined, and so it was okay that if you knew where the area was going to be bad, it would not be that big a deal. You just tried to stay out of there with your cell phone. And those were places like X-ray rooms, MRI areas. But now what we're seeing is that with the advent of mobile imaging devices, almost every building in the hospital can almost be considered an imaging space. So every OR, the different clinics, the radiology clinic, the cardiology clinic, the endoscopy clinic, all those areas are now capable, because of mobile diagnostic equipment, of becoming imaging areas. And so they have to be shielded accordingly. So now we see this pervasive increase in the amount of shielding that goes into the hospital infrastructure. If you now combine that with the fact that hospitals are also really, really good at reorganizing fairly frequently. So where you go today and it's the endoscopy area, in 2 weeks it could be the accounting area. And so just because you moved the accountants in, you didn't change the wall structure and remove the shielding. You just moved the endoscopy group to a different area and put up more shielding there. So there's this constant moves, adds, and changes that are going on that result in hospitals being notoriously difficult to be able to provide reliable cellular coverage inside from the outdoors. So you take a look, this is what we consider to be a typical hospital. You got a lot of different things that are going on. So you got a lot of different services that are being run on lots of different networks. So you got your cellular voice and data. That's the folks that are using their personal devices or maybe the company issued devices over the cellular network that's going on. So those are smartphones and PDAs and tablets and that sort of thing. Then you've typically got a separate wireless LAN that's deployed. And that's for a lot of different reasons. You could be using it to do real-time locating of the different pieces of equipment and maybe personnel. But that's typically run over a wireless LAN or a 802.11 type of network. Then you've got building automation, so making sure that the lights are off when there's nobody in a particular area, keeping the temperature low when there's nobody in there, and then adjusting automatically as people move into those different areas. And of course, you've got public safety, and that's the ability for your first responders to be able to communicate when they're inside the building as a result of an emergency or something. So that's your police, your fire, your EMTs. But you end up with multiple separate wireless systems that are all on different frequencies, and they're being deployed either house-wide or departmentally. So your wireless medical telemetry wouldn't necessarily be down in the cafeteria. It's only in the patient area. Public safety, you may have good coverage on your upper floors. You may need to just put public safety into the lower portion of the building that's below grade. But all these different separate networks create issues. There's issues with maintenance. There's industry issues with monitoring. And then every time you have to make an adjustment in one of those networks, you have to open up the ceiling potentially. And that creates a higher ICRA or ICRA risk and ICRA cost that's associated with it. So what we would like to propose is a more integrated solution using a couple of options that we have available in our portfolio. So if you look at this slide, it introduces you to the two main solutions that Corning Mobile Access puts out into the marketplace. On the left-hand side, you see the Mobile Access 2000, the MA2000 solution. This is a multi-carrier, multi-service, broadband distributed antenna system. It has the ability to support, like it says, multiple carriers, so AT&T, Verizon, Sprint, T-Mobile, US Cellular, if you're in the Chicago area, Metro PCS, different folks. They can all plug into this DAS and it will handle them effectively. You can also do multiple services. So in addition to that commercial cellular from the carriers, you can also support wireless medical telemetry. You can do 800 megahertz trunk radios, so your facilities group can use their push-to-talk devices to communicate with each other. You can put public safety onto this. Basically, if it's a licensed spectrum application, you can put it onto the MA2000 solution. It's a great solution if you've got a large environment with a very complex RF set of requirements. On the other hand, on the other side of the page, you see our VE. VE is a very unique solution in that it provides, let me back up for a second. So the way that the MA2000 works is using a hybrid fiber coax solution. That's how we can make it broadband. So the connectivity in the backbone is provided by single-mode optical fiber, which has an infinite amount of bandwidth in the distances that we're talking about being able to support. And then it's got 50 ohm coax that runs out to the antennas. And we'll talk a little bit more about that at the architecture side. But that coax is also broadband and has the ability to support multiple carriers and multiple services. So with that, we'll move over to the VE again. So VE uses cellular delivery over existing LAN infrastructure. So instead of using a hybrid fiber coax solution, it uses the existing Cat5e or better horizontal cables that already exist in the facility. It does not do all the things that MA2000 does. So instead of being multi-carrier, multi-service, it's really a multi-carrier solution. It can support one or two carriers and deliver commercial cellular services into an environment, or facility. It does not do public safety. It doesn't do wireless medical telemetry. It's designed to do one thing, and it does it pretty well. The cool thing about it is because it does use existing infrastructure, it provides a lower entry cost for being able to provide cellular service. And we'll talk more about it in just a second. But first, let's talk about the Mac Daddy. So the MA2000, it slices, it dices, it makes mounds and mounds of julienne garnish. It does all kinds of things. It's a very cool solution because it's both scalable and flexible. So when we say it's scalable, you can put the infrastructure in place and it can support a specific building, a couple of floors in a building, or the entire building. And then if you need for it to scale up to support a new addition, a new wing, or something like that, the head end is, or the infrastructure is capable of supporting it. So it allows you to do modular addition for new buildings, for new structures, or to add new services or carriers. It's very easy to add capacity to the MA2000. It's the only DAS solution that has that integrated support that we talked about for GE Healthcare and Philips wireless medical telemetry solutions. The way that the broadband infrastructure goes into place is it creates what we call a wire-at-once infrastructure. So once you've got that hybrid fiber coax network installed, it allows you to add services and add capacity very easily without creating a lot of disturbance in the physical portion of the hospital, the facility itself, or to the activities that are going on inside the hospital. It's also very reliable, very IT-friendly, provides you with the ability to do end-to-end monitoring, everything from the RF signal source all the way out to the antenna. And it has a low power consumption, which is very important once you start talking about throwing multiple carriers and multiple services onto it. And then finally, it's qualified. We've got 20 years of experience doing hospital installations, and the MA2000 is the system of choice for doing healthcare installations for Verizon Wireless, AT&T, and Sprint. So how does it work? We can take a look at this on this slide, the architecture slide. Essentially what you have is the four elements that are common to any distributed antenna system. You've got a head-end unit that's located in an MDF. The head-end unit takes the incoming signals from the different carriers, so Verizon Wireless, AT&T, Sprint, T-Mobile, Public Safety, wherever the RF signal is, it takes that incoming RF signal, cleans it up, and converts it into an optical signal. And then that optical signal travels over the single-mode optical fiber from the head-end up to the IDS, or to the telecommunications closets. At the IDS, or the telecommunications closets, we have what's called the remote. The remote just simply undoes what the head-end did. It converts that signal from opticals back to an RF environment and puts it onto those coax cables that you see there at the top that go out to the individual antennas that are in the work area. That coax run is using, it's not your typical cable TV coax. It's not the stuff that you see when you get DirecTV or when Comcast or Charter or Time Warner come to your house to set things up. What we're talking about is a 50-ohm coax cable that I think the industry term for it is BHC, big honking cable. You can take and hold a 10-foot section of this out at arm's length and it will not bend. So it requires a certain amount of skill to be able to pull this stuff in to terminate it without damaging the cable. But it is a broadband solution, so it enables you to support everything on that DAS from any licensed application from 400 megahertz up to about 6 gigahertz. The way that the thing that makes the MA2000 special compared to other hybrid fiber coax solutions that are out there is the way that you can expand it. So if you needed today Verizon Wireless and Public Safety, you would, and it's not as simple as this, but it's a good way to think about it. You would simply buy a Verizon Wireless module and a Public Safety module, and you'd plug it in at the head end and at every remote. And then you'd be able to pump sweet Verizon RF throughout your facility and provide support for your emergency responders. If later you decide that you needed to add AT&T and Sprint, you'd buy AT&T modules and Sprint modules, plug them in at the head end, and at every remote that you needed to service with that particular that particular carrier. So if you only wanted AT&T on the third floor, you'd plug in AT&T on the third floor. If you only wanted Sprint on floors 7 through 10, you'd plug in the Sprint modules at the remotes in 7 through 10. That modularity is unique to Corning Mobile Access at the remote. All systems are modular at the head end, but we're the only ones that offer that kind of modularity at the remote. So it allows you to buy what you need today and then expand that to what you need when you need it. One of the other things that's unique about this is that those coax runs that come out, you can typically get a one-to-one correspondence. Every coax run goes to an antenna. But in a hospital, you end up with a very, very kind of chopped up environment. So you may end up in an area where you've got lots of examining rooms or your operating rooms are close by. If those areas are shielded, you're not going to get a lot of signal into those rooms. With the MA2000, you've got enough power out of that remote that you can then split the signal coming out of the coax to go to multiple antennas. In an OR room or in an examining room, you typically don't get a lot of people. So you can have a very low signal power out there and still be able to support them. So out of one remote, you could support maybe 30 different rooms. On the other hand, if you've got an auditorium where you're bringing your staff in to do training, to have presentations, that sort of thing, and you get a large concentration, you may want to have a dedicated antenna with a dedicated coax run. So the MA2000 gives you that flexibility to deliver the required amount of signal the most appropriate way and do it cost effectively. So MA2000, it scratches a lot of itches. Again, we talked about the fact that it's integrated with the GE CareScape. So GE Healthcare's CareScape is actually a white-labeled solution. We manufacture it, the MA2000, and provide it to GE Healthcare for their deployments. The folks on the phone that are familiar with GE CareScape know about this. It enables the efficient management of what they call their clinical information logistics program across the entire hospital by making all the patient data available, no matter where the healthcare provider might be, whether they're on the floor doing rounds but they're in a different area, if they're in a different wing, or even if they're down in the cafeteria. Similarly, the MA2000 integrates with the Philips IntelliVue solution as well. So using that dedicated 1.4 gigahertz spectrum that they use for what they call the smart hopping network, we're able to provide that centralized surveillance and clinical decision support and immediate access to patient information. Moving from the MA2000 to the VE solution, the VE is a little bit different. So we talked about the MA2000 being the Mac Daddy and being able to support multiple services and multiple carriers. VE doesn't do that. VE is a way of extending cellular coverage into a building. It's good for getting coverage to an office park. It's good where you've got a lot of doctors who are going to be assembled. It's good for providing cellular coverage to a lobby area where you don't need a lot of other things. But it's ideal for doing that because it uses the existing horizontal cabling infrastructure to reduce the amount of labor that's required to do the installation and the amount of material that's required to do the installation. The cool thing about it is the only DAS solution that's tested, approved, and recommended by Cisco. And the reason that Cisco likes this solution is because they've tested it extensively and they've documented that it has no impact on the LAN or wireless LAN input, operation or monitoring. The other thing that's cool about it is that when it goes in, because it takes advantage of the existing infrastructure, it's fast. And fast means that it's less disruptive, and it'll install in days as opposed to months that you would see potentially with a standard hybrid fiber coax solution. So those are the features and benefits that are around VE. So how does VE work? VE works by sharing space on the existing horizontal infrastructure that you have in your building. So as IT managers, you probably got Cat5e or Cat6 or better solution running all over the hospital. Well, VE will work with that existing infrastructure. The way that it works is if you're running a wireless LAN today, and it will work with a LAN, but we like using the wireless LAN because you've already got the access points that are out there. But if you're working with a wireless LAN today, you would typically have that switch in the closet, and then you would have a cable that ran from the switch out to the wireless access point. Well, what we do is we take and interrupt that flow. We keep the same cable, but we take and plug in a cellular controller. And then we plug the Cisco switch into the cellular controller and the RF source from the carrier. They both go into the cellular controller. It then takes and puts those combined signals onto that Cat5 or better cable that goes out to the access point. Just short of the access point, we're going to drop in our pod. What the pod does is detects and distributes the incoming cellular signal, but passes the data traffic through to the wireless access point so that it can distribute that signal to the right places. The way that it does this is that we don't operate in the same frequencies that the Ethernet traffic or the wireless LAN traffic operates in. Those Cat5e, Cat6 cables are rated at 0 to 100 megahertz. We take the incoming RF signal, shift it to an intermediate frequency that is above that, say 140 to about 300 megahertz, and we put it onto the same cables. So even though they're sharing space, it's almost like they're in separate lanes on a highway. It's kind of like you guys are in the, your LAN traffic is in the commuter lane, and then we're occupying the other lanes. But it creates the effect of having separate networks. The other thing that we do is we provide power for our pod out of the controller using PoE. We take the PoE from the Cisco switch and pass it through both the controller and the pod to the access point to create two separate systems so that if our solution goes down, the wireless LAN stays up. If the wireless LAN goes down, our solution stays up. If it's a huge natural disaster, we may both have issues, but that's outside of our control. But the goal here is to create a way of distributing commercial cellular using the existing wireless LAN. Now, one of the things that, well, actually, let's go to the architecture slide, which is the next one. So this is how VE looks as it's deployed. You've got the VE controller, and the controllers can act as either masters or slaves. So again, looking at the four elements of the DAS, we've got a head end, we've got remotes, we've got antennas, and then we've got cables that connect all those things. So in the MDF, you have a master controller. That's where your RF sources would plug in. That's and we would go up to the remotes. Now, in this case, this is where you would probably need to install new infrastructure because VE requires either a shielded Cat6, Cat7, or cable TV coax or optical fiber to run in there, single mode optical fiber. So if you've got those media in your backbone, then you're in great shape. Otherwise, you might have to pull it. But once you get to the closet, we would have a slave VCU or a controller, and that would be tied to the master. From the slave, we've got the existing Cat5 or better infrastructure that runs out to the access points, and that's where you deploy your pods. Now, our pods operate at cellular frequencies, which are typically much lower and have better propagation characteristics than the wireless LAN frequencies. So you would not need a pod for every access point. Instead, we get about 8,500 to about 10,000 square feet of coverage out of a pod. So what we typically see is that you would deploy a pod for about every third, maybe every fourth, depending on what you've got set up, access point to be able to provide that cellular solution into the facility. So that's the way that VE works. Again, it takes advantage of the existing infrastructure. Because it does that, you reduce the amount of labor that's involved, you reduce the amount of material that's involved, and enables you to bring that cellular coverage in at a much faster deployment and a lower price. A couple of examples there, that you can see on your screen. MA2000, we deployed that at Northwestern Memorial Hospital in Chicago. 897 beds at the time, and we're doing a lot of different things on there. And this is what MA2000 is good at. We're doing wireless LAN, we're doing telemetry, we've got cellular, we got public safety, everything traveling over that one infrastructure and providing services to the entire hospital. It's designed to support campus growth. So we knew when we went in there that they had the main hospital building, but they were already planning another satellite building on the west side of the campus. So knowing that information going in, that system is sized to go ahead and support that just by running the additional infrastructure, the cabling infrastructure, to the new building when that time is required. But the head end is already set up to be able to support that. So again, a single network with support for modular addition of new services when they're required. On the right-hand side of the screen, you've got a completely different situation. This is Florida Hospital in Kissimmee, Florida, in the Orlando area. Their requirement was to provide cellular coverage for Verizon Wireless into this facility. So this is one of the organizations that has created for their folks a contract with Verizon Wireless, so that's what they were interested in supporting. So what we were able to do then is to go in there. We didn't have to run new cabling in the horizontal. We were able to go in and take advantage of what they had available and then plug into that. As a result of that, we're able to deliver cellular coverage for Verizon Wireless in that facility. What would have taken a month to do took only 5 days, and we did it without consuming any of their LAN capacity. So again, two different examples of how things deploy and how they can be used. So our final slide, why choose Corning Mobile Access? Well, hopefully we've given you a couple of different good reasons. The first is 20 years providing enterprises with flexible, scalable solutions for solving in-building wireless issues. A demonstrated track record in over 350 hospitals across the U.S. It's a modular architecture. It enables you to buy only what you need and only when you need it, but still support graceful expansion of services and carriers using that broadband infrastructure. We've got integrated support for GE and Philips wireless medical telemetry solutions and the ability to choose a solution that's best for your venue. If you're doing a lot of different services, you can take advantage of that MA2000, the multi-service, multi-carrier broadband solution. If you just need to expand cellular coverage into a particular area, you don't need public safety, you don't need wireless medical telemetry, we can do that using VE and do that at a relatively competitive, a very competitive price point. And with that, I'd like to open the floor to questions.
Thank you very much, Alan. That was excellent, and we appreciate the information that you provided today. I wanted to remind everybody that they can ask a question by looking in the dialogue, typing a question in the dialog box on your screen. If you don't see that dialog box, there's a red icon there that says Q&A, and you can type your questions in, and we'll get to them. While we're waiting for the questions to come in, I believe Eric has a question he'd like to ask you.
You bet. Thanks, Alan. That was a great presentation. Appreciate it. You had mentioned that you support both the GE Healthcare, CareScape, and Philips IntelliVue. How common is it today for hospitals to be combining cellular and other wireless services with wireless medical telemetry on the same DAS?
It's a great question. The way I explained it, it sounded like it was pretty much a homogeneous deployment. In reality, it all comes down to the individual, and like most things when it comes to RF, unfortunately, it comes down to it depends as an answer. And so what we see is different healthcare systems are doing things differently. The majority of time what we see is that the wireless medical telemetry deployments are dedicated deployments, that they don't combine those with cellular. But the fact that they are going in and creating that wireless medical telemetry environment gives them the opportunity then to expand cellular into different areas of the hospital that maybe didn't have good service before. But we typically see it as a dedicated deployment.
A question came in about whether there would be a copy of the presentation, and the answer to that is yes. If you go to graybar.com and click at the G2 Talk webinar logo, you'll see a link there to the archive. The archive will be up there tomorrow. Alan, a question came in about technical support for the MA2000. We believe that's probably handled with an integrator that may be providing a certain type of service level agreement with the end customer. Is there anything that you wanted to expand on technical support for the MA2000?
Sure, absolutely. One of the things, the way that Mobile Access goes to market is through a network of systems integrators, value-added resellers, VARs, that we provide. The equipment is available, of course, through Graybar, but these guys, if you look at a DAS, we break the deployment into three pieces: smarts, parts, and hearts. So hearts is installation labor. These are the folks that actually come in and they pull the cable and they do all the things that are necessary to put the parts in place. And the parts are the actives and the passives of the system. The smarts is the domain of the systems integrator. And that's the ability to evaluate what the RF environment is, to accommodate changes to that RF environment, and to take care of the maintenance. So typically when this installation goes in, the VAR has the lead role in doing that to make sure the system works, and then also would typically take responsibility for the technical support of the platform moving forward. So the hospital would enter an agreement with, if it's an enterprise deployment, in other words, the hospital pays for it, they would probably enter the agreement with the VAR directly. If it's a carrier-funded deployment, and Verizon or AT&T or whoever that carrier is paying for the deployment, that contractual obligation would fall on the carrier to establish with a VAR to support the network. Did that help?
Yes, it did. I think Eric's going to respond to a couple other questions here.
Yeah, so Alan, got a question about about the Mobile Access VE system. What if a particular facility has a non-Cisco wireless LAN infrastructure? Are they still able to use VE?
Absolutely. It works with any wireless LAN vendor. We just like saying Cisco because they're the 600-pound gorilla, and we want to get that halo effect that's associated with it. But if you're using Ruckus, or if you're using, oh shucks, now everybody else just flew out of my head. But if you're using another wireless LAN vendor, it will absolutely work with those guys. Great question.
Thank you. Got another question came in. How can you determine whether or not public safety can ride on a DAS alongside of other technologies, or if it may be required to be a standalone system?
But there are a couple different. This is a really good question. Public safety is such a touchy topic because it's so fragmented. Public safety typically falls to the requirements of the municipality where it's being deployed. So there are some municipalities that make it very, very simple. If you go into the associated code that's associated with it, whether it's the building or the electrical or wherever you find it in your particular area, it may simply say that public safety cannot share with any other application. So that makes it very, very clear. If you're in a municipality where it's not as clear, it comes down to what you want to do. Public safety is a completely different beast from commercial cellular. The radios that are used in public safety DAS are much more powerful. They can have up to 5 watts of transmit power, whereas a commercial cellular device only has about a half watt of output power. They typically operate at lower frequencies, which have better propagation characteristics. So what we typically see is that you'll have an overlay to support the public safety on top of a dedicated commercial cellular network. So what you may have is a couple of antennas that are spread throughout your building to support public safety on a dedicated coax run, and then you would have the rest of the building run the commercial cellular with multiple carriers on it. It's really, again, it's an it depends issue. If you're trying to save money, we recommend an overlay. If you've got money to burn, we'll be happy to do it however you want to do it.
Great, thanks, Alan. So got another question came in here regarding approval. So as we're talking about the Philips and the GE Healthcare solutions, is there a need for approval from those organizations in order to combine that with other wireless technologies on the same DAS?
It's a good question. What we typically see is that when the wireless medical telemetry systems are deployed, they are deployed typically by Philips or by GE Healthcare. So to say that you would need their permission, it's not quite that way. Those guys would deploy the wireless medical telemetry. We would then supply the commercial cellular as an overlay on top of that. So we wouldn't get involved in the deployment of the WMTS portion of it. We'd leave that to the guys that are really, really good at doing that. So I think that answers the question, but I'm not sure.
Yep, I think that does. So one other question came in here. What types of RF sources are the cellular carriers connecting to the DAS today? I know there's been a lot of transition in what they're doing, and how does that impact your choice of a DAS?
That's a really good question. So historically in the space, the only option that the wireless carriers had to provide coverage was to use a base station. And they could use a base station in one of two ways. And the base station is that big piece of equipment that sits at the bottom of every cell tower. So they had the option of either putting that base station in the building, and if you had a very large building that had lots of occupants inside it, and it doesn't have to be a static number of occupants, it can be just a number of occupants that traverse that facility, say, in a given year. So with a hospital, you've got lots of turnover in there, so you could end up with hundreds of thousands of people who might be in there in a given year. If you've got that kind of capacity issue, you attract a carrier interest. They may dedicate a base station. On the other hand, if you've got a smaller facility, the wireless carrier may have chosen to feed that using what's called a repeater or a bidirectional amplifier. And the way that system would work is you would have a donor antenna that would be located on your building, typically on the roof, and it would point at an active cell site nearby. And it would take the capacity from that cell site and just redistribute it inside the building. That's the cheapest way of doing things, and so carriers really liked doing that for a long time. But with the transition from voice to data, we're seeing fewer and fewer deployments of the repeaters because repeaters tend to add noise to the system, and data works best in a low noise environment. So we're left now with the idea of the base station being the only way to deploy things. Well, base stations tend to be expensive. Carriers realize that they've got to put coverage into more and more buildings, and they need a better way of doing that. So they're moving to a technology that's generically called small cell technology. So small cell technology is basically having the equivalent function of a base station without the size and the expense of doing a base station. So you'll hear people talk about picocells or enterprise femtocells or microcells. Those are all just smaller RF devices with less capacity than a base station, probably less, or it's definitely less power than a base station, but it's an attempt to size the RF source to the size of the opportunity as a way of reducing the cost of deploying coverage. So if you move forward today, you may end up with, say, Sprint might come in and say, I'm going to deploy a couple of microcells. Verizon may say, I'm going to deploy a base station and a repeater. I'll use my repeater to do the voice coverage. I'll use my base station to do the data coverage. So there's lots of different RF sources that could be used to solve the problem. And it'll be highly dependent upon the carrier and also the region that the carrier is operating in whether it's a high noise environment like a dense urban or whether it's a more suburban type or rural environment. So that it would come down to them as to what type of source that they deploy. The good news is a DAS can accommodate almost any RF source. So if it can convert it to RF, we can plug it into the DAS and use it to distribute coverage throughout the building. That was
Great,
a long answer to a short question.
It is, and it's a complex topic, and it's good. It's definitely a topic you cover in depth when you work with the carriers on your solution. We've got several questions coming in here, a variety of topics around the VE product. So I'm going to try to group them together here for you a little bit. But you talked about using existing Cat5 cable, mentioned Cat6, 7. So what are the cable requirements for the VE system? We also had a question about how many pods can be supported off of a controller on the VE system.
Well, let's start with the second one first because it's an easier answer. Actually, they're both relatively easy, but I probably need a little time to explain this, the first question a little bit more. Each VCU can support up to 12 pods. So if you've got 12 pods out there, each pod covers about 10,000 square feet, so you can cover easily about 100,000 square feet out of a single VCU. The important thing to remember about VE, with the answer to both of these questions, is that VE does one thing. So if you just need that one thing, it's a good topic of discussion. But if you need to do more complex environment where you're deploying 3 or more carriers, V is really not going to be the best solution for that. Going to the first question, which is what cabling, could I make up my mind on what cable is required? I probably didn't differentiate as well as I should have. The existing Cat5e or better cable is the stuff that's in the horizontal. So if it's in the closet already running out to the wireless access point, we can take advantage of that. It's that connectivity between the slave remote and the master the master VCU and the slave VCUs that requires the shielded Cat6, Cat7. So I need to differentiate between the horizontal and the vertical. So in the vertical, that's where you need the shielded Cat6, Cat7, or fiber, or the cable TV coax. In the horizontal, you can take advantage of the existing Cat5e or better. Did that do a better job?
Yeah, Alan. Hey, this is Carl. I think the question about the pods wanted to know about in the IDF. So if you have a slave unit, how many pods can go on the slave?
Well, each VCU can. Okay, so if you've got I have to back up to do this a little bit better. So in the master VCU, each master VCU can support 12 slave VCUs. Each slave VCU can support 12 pods. Is that better?
So the total would be 144.
Correct.
12 times 12.
I don't do public math, but that is the right answer.
Thank you. I'll hand it back to Eric.
Great. So I think we've got kind of a Mobile Access 2000 question here related to whether it works with both VHF and UHF when you're bringing radio systems on board to it. And I'll kind of add to that a little bit with some other questions here and wondering which types of wireless technologies can safely be run over that same common DAS infrastructure.
It's a great question. You guys are loaded with them today. It does not support VHF. VHF typically is down in that 150 megahertz range, and unfortunately we don't support down there. There are ways of doing VHF deployment, but the beautiful thing about 150 megahertz is it typically doesn't need a lot of help. It's got great building penetration characteristics and can typically reach most places. So we are, and most DASs are set up to do this, that they provide a broadband infrastructure for what we call licensed applications, licensed spectrum applications. So if you have to get permission to use that spectrum or you have to pay for that spectrum, it's typically a licensed application. We don't work with the unlicensed stuff because it's just too fluid. So that's the 802.11, that sort of thing. But if it's a licensed spectrum application that operates between about 400 megahertz and 6 gigahertz, you can put it onto the DAS. Now, you'll need to work with your systems integrator and let them know what it is that you want to do, because they'll need to design appropriately to accommodate for different output powers and that sort of thing to ensure that there's no interference. But the DAS itself is capable of accommodating licensed spectrum between 400 megahertz and 6 gigahertz.
Excellent. So we're running up against time here. I know we've run a little long, but it's been very informative. We're getting lots of questions. So we're going to do one more question, but I just want to remind everybody, any questions that you've submitted online here, we will certainly answer by email after the call is over. So we'll be sure to get any questions you have answered. But the last question here, is it necessary to gain carrier wireless service provider approvals when deploying a DAS?
Oh, wow, what a great question. Yes, the fact that these are licensed spectrum applications means that there is a license holder. In the particular case of doing commercial cellular, that license belongs to the carrier, and you must have the carrier's approval prior to deploying anything that rebroadcasts or retransmits their signal. So great question. And again, that falls on your systems integrator. Your systems integrator should take the responsibility to the deployment to do the carrier negotiation portion, to do two things. One, to get that permission, and two, to guarantee their support for that DAS as they move forward, that they will plug into it. So great question.
All right, Alan, we thank you very much for the time that you spent with us and the hospital clients that are on the phone with us today. This has been a great conversation about DAS. So I just wanted to remind everybody to, if you're one of the 50, check your email to see if you got a coffee certificate. Let you know that these are that the presentation is archived. You can go to graybar.com and pick up a copy of the presentation and get to hear it again. The other thing I wanted to mention, there may be a question that comes to mind later on that we didn't get to answer here. I wanted to give everybody the opportunity that they could send that email directly to me. That's Carl with the K, K-A-R-L .Griffith, G-R-I-F-F-I-T-H, carl.griffith@graybar.com. If you'll email me with any additional questions or concerns or anything, I'll make sure that it gets to the appropriate people so that we can respond to your questions. We appreciate your attendance today. We know we ran a little bit long, but there were so many good questions we just couldn't cut it short. So Alan, thank you very much. Eric, thank you very much. Everybody have a great day. Thank you for being part of our presentation today.